So let's talk about angles in the first quadrant. We are talking about the trigonometrical ratio of angles in the first quadrant, the sine, the cos, and the tan of angles in the first quadrant. So we already defined angles in the first quadrant to be angles that 0 is less than them, 0 degree is less than them, and they are also less than 90 degrees. So now here we are saying that where the theta is an acute angle, and based on our previous discussion, we already know that that angle has to fall in this area of this quadrant. It has to fall inside here. Now for us to now understand this perfectly, we are going to do this. We are going to bring out an hypotenuse of a triangle, because we shall be forming triangles in all that we are doing. Now I'm going to bring this down here to form a right angle. No doubt, based on what we have seen, we have taken this area to be theta. So this is the theta, the angle that is lesser than 90 but greater than 0. Don't forget that we have 0 here. So for us to be able to understand this, let me keep this hypotenuse as 1 and take this side as the positive y, which is parallel to the positive y. I hope you can see that. And for this side, I'm going to have a positive x, because it is parallel to the positive x. Now let us talk about the sine of this angle, the cos of this angle, and so on and so forth. So we are going to have the sine of angle theta, and we know sine is opposite over hypotenuse. So this is opposite, which is what? Positive y divided by the hypotenuse. So we have a positive y. I hope you see that. So then if we are looking for the cos theta of this angle, this is going to be adjacent over hypotenuse. So we have positive x over 1, and this is going to give us what? This is going to give us a positive x. What about tan? We have that tan of that angle should be opposite over adjacent, and the opposite is positive y over positive x, which is also going to give us a positive angle. So what can we deduce from this? We can deduce that in the first quadrant, all the angles that we are going to find that are of the trigonometrical ratios are always going to give us a positive angle. And this is what you just have to check in your four-figure table or your mathematical table to see the sine of that angle, the cos of that angle, and the tan of that angle. So you are going to get a positive value for all of them. Now let's talk about the second quadrant. Now let's talk about angle in the second quadrant. So like I have defined it earlier, I said angle in the second quadrant are the angles that 90 is less than them, but they are also less than 180. A very good example is angle of 91, 92 up to 179. So if I am required to find the sine of an angle that is an obtuse, which is greater than 90 but less than 180. For instance, if I'm required to find the sine of angle 120 degree, how can I find angle 120 degree? So this implies that starting from 0 degree, if you don't forget, starting from 0 degree, 120 degree has taken us into the second quadrant. Now, how do we now find the sine of 120 degree using our four-figure table? All we have to do is find the remaining angle in this side. You remember that the sum of angle on the straight line is 180. So what will be the remaining angle inside here? All we have to do is just to take away this theta from that 180. Then we have 180 degree minus theta. I hope you can see that. So which means if I'm given the sine of an angle and the angle is theta, which is obtuse, that means I should be looking for something equivalent to the sine of 180 degree minus theta. Meanwhile, what is going to be, will there be any changes in what I'm looking for? This is how I'm going to know. Let's talk about the sine of this angle that is over here. The sine of 180 degree minus theta, which is in the second quadrant, is going to be what? This is opposite over hypotenuse. So we have positive y over 1, which will give us a positive y. But let's look at the cos of this angle. The cos of 180 degree minus theta. This is going to be the adjacent, which is negative x. You can see it falls on the negative side of x. So we have negative x divided by 1. And this is giving us minus x. Let's check the tan as well. The tan of the angle, which is 180 minus theta, we are going to have opposite over adjacent. And that is positive y over negative x. And this will give us a negative y over x. What can we deduce from this? We have seen that of all these three angles that are greater than 100 and that is greater than 90 degrees, it is only the sign of it that is positive. It is only the sign of it that is positive. All other ones are what? Are negative. What does this imply? It implies that if I am required to find the sign of 120 degree, the sign of 120 degree is equivalent to the positive, you can see, the positive of sine 180 degree minus 120 degree. And this is going to be the positive of sine 60 degree. Can you see that? So this implies that if I'm looking for sine 120 degree, I can simply check my four-figure table or my mathematical table to check the positive of sine 90 and I'll get the same answer. What about if I'm required to find the cos of 120 degree, the cosine of this angle? From what I have seen, it is going to be negative. So I'm going to write negative the cosine of 180 degree minus 120 degree. And this is going to give me the negative of cosine 60 degree. And the same thing applies to the tan of it. The tan of 210 degree, the tan of 120 degree is equal to the negative of tan 60. And this has helped me to see what I just have to check in my mathematical table. If I'm looking for tan 120, I just have to check tan 60 from my four-figure table or my mathematical table and attach a negative sign to it, and I'm done with that. So this has given us the solution to the first three parts of the questions I gave you at the beginning. Now let's move on to the other part, the third quadrant. So if we are required to find the sine of 210, how do we find it? Let's go on to the next part.